Example 1 here on sequences is taking a look at the arithmetic and geometric progression. And we've got two parts to this example 1 here. We've got part A where we're given an arithmetic progression and part B where we're given a geometric progression. So let's start with part A here. For part A we have an arithmetic progression and we can see our first few terms here are 3, 7, 11, 15 and 19. And we want to find A and D. And then we also want to predict the next term. So to start with, let's find A and D. Well, A is really simple. In this case, A is just simply our first term. So A is the first term here. So in that case, A is simply 3. Now D represents the difference here, so that's the term-to-term rule. So for example, what do I add to 3 to get to 7? Well, in that case, we could also work backwards here. That would be 7 minus 3. Therefore, D is simply the difference here. This is the difference here, and as we can see, that's clearly 7 minus 3, giving us 4. Okay, so that's A and D. Now we need to predict the next term. So to do that, we use our formula here for UN. Okay, and this represents our nth term here. Well, in that case, that's going to be A plus n minus 1 times D. Well, that's going to be 3 for A plus n minus 1 times by D, where D is 4. So that's going to be 4 times by n minus 1 in this case. All we simply need to do now is use the fact that we're looking for the 6th term. This is the first 5 terms here, so the next one is going to be U6 then. All that means we need to simply replace our n here with 6. So this is going to be 3 plus 4 lots of 6 minus 1. And simplifying here, this is going to be 3 plus 4 times 6 minus 1, which is 5. We've got 4 times by 5. And if you evaluate this here, we get 20 plus 3, giving us 23. Okay, I mean, we could clearly see here, if we add 4 to our last term here, which was the 19, and 19 plus 4 would give us 23. However, the magic of this here is we can easily work out, for example, the 50th term easily by substituting n equals 50 into that. Okay, so that's part A there. Let's take a look now at part B. And for part B, here we have a geometric progression. Again, we're asked to find A and R this time, and then we're asked to predict the next term. And again, A just simply represents the first term. So A is the first term, and R represents what we call the common ratio. Okay, you might just see that sometimes know it as the ratio. And the ratio here is what we multiply term to term here. So for example, if we start at 6, what do I times 6 by to get to 30? Again, taking that idea here, if I am on 30 here, to my next term, what do I times 30 by to get to 150? And you can easily deduce the result of this by taking the second term, for example, and dividing it by the previous one. So in that case, the common ratio is going to be 30 divided by 6, giving us 5. Okay, and you could verify that again by doing 150 divided by 30. And again, you would notice you get 5. And let's not forget our first term here, which is simply 6 there. Okay, so we have A and we have R here. Now we can simply work out the mth term again. Okay, or using the mth term, we can work out the next term. So here, our mth term is going to be which is going to be equal to A times R to the n minus 1. Well, A is 6, so this is 6 times by R, which is 5 to the n minus 1 here. And all we need to do here, again, as we're given the first 5 terms, in that case, we simply need to replace this n here with a 6. We're looking for the 6th term now. And again, all that means we need to replace our n here with a 6. So we obtain 6 times 5 to the 6 minus 1, which gives us 6 times 5 to the 5. And in this case, if we evaluate this, this gives us 6 times 3,125, giving us 18,750 there. Okay, so that gives us the solution there to example 1. Example 2 here on the properties of sequences is asking us to prove that the sequence defined by an minus 7 is increasing. So to do a problem of this type, First, let's just note down that this an minus 7 actually represents our nth term. This is un. So an minus 7. Now, if we want to prove that a sequence is increasing, what we would need to do here is take, let's just say, our term here, un, and then we need to subtract the previous term from this. Let's say un minus 1. And if this is increasing, what we should obtain here is a number larger than 0. If that number is less than 0, then that's a decreasing sequence. So what we would expect here is that in that case, this is greater than 0. And un minus 1 is simply replacing n here with n minus 1. This is a lots of n minus 1 minus our 7. So therefore, if we take this un and we minus un minus 1, what we obtain here is an minus 7 minus, and what we'll do here is write this all in one bracket so we don't accidentally get tripped up here with the minuses, a bracket n minus 1 minus the 7. Now here, just be slightly careful working with these negatives here. Clearly this an minus 7 won't change just yet. In this case, this is minus 8 times n minus 1 and then minus 7. So that'll become positive 7 there at the end. Okay, so minus 8 times n gives us minus an, and then minus 8 times minus 1 gives us positive 8. Okay, so again, we just have to be slightly careful here with our negatives. And we also have this minus of a minus 7 here, giving us plus 7. And here now, all we need to do is just take a look across here and collect like terms. So we have an minus an, so they just simply cancel there to give us 0. We have minus 7 and plus 7, and again, they're just going to cancel. So simply, all we get left here with is positive 8. And therefore, as we just said, as this is bigger than 0, so therefore, a is larger than 0, that shows us that this is an increasing sequence. Because what we can show here clearly is that un is greater than un minus 1 here. So therefore, it's an increasing sequence. And that gives us our solution for example 2 there.